11.1 notes. Nth roots and fractional exponents. That's kind of a funny thing to say, nth roots. It's kind of hard to say, actually, if you try it. Nth roots. So, let's see. You are familiar with some roots, but we're going to learn more. So, let's do some definitions here. What is this statement asking for? Square root of 25. What is the square root of 25? 5. Why is 5 the square root of 25? 5 equals 25. Because 5 squared equals 25. What is this statement asking you for? The cube root of 27, and the answer to that is because 3 to the third power equals 27. What is the fourth root of 16?
2.
Why?
Because 2 to the fourth power equals 16.
Thank you. Because 2 to the fourth power equals 16. Do you see a pattern?
Yeah. Yes.
What do you notice?
Numbers.
Beyond just numbers.
Huh?
Do you notice that in the definition, this matches the little number out in front?
Yeah.
In every case, except for one. Which one?
The first one.
The first one. This technically has a 2 there, we just can't see it. When it's a 2, we don't write it. Okay? What's this one asking for?
The cube of negative 125.
Wait, did you possibly do the same?
Cube root of negative 125 would be what?
Negative 5.
Negative 5, because negative 5 is what you raise to the third power to get negative 125. What is the fourth root of negative 16?
2i.
Thank you. It is 2i, because 2i to the fourth gets you negative 16. Does it?
Yes.
I times I squared. I don't even think 2i to the fourth does it?
Yes, it does.
I times I is I squared, and I squared is negative 1. It would be positive 1. That doesn't work, does it? Because I to the fourth is 1, not negative 1. So it actually doesn't work out for us. No, there's no answer there, because we have issues with negatives sometimes. We have issues with negatives when they are under even radicals. You can have a negative under the odd one, right? Because something to an odd power can be negative. But we can't have a negative under an even power. That causes an issue. Okay? So, I've been avoiding the term long enough, but this number out in front has a special name. It is called the index of the radical. Okay? So, the index here is 4. The index here is 3. Index here is 4. Index here is 3. What is the index here?
2.
2. We do not write an index of 2 because a square root has an assumed index of 2. Okay? Same reason why if you have something like that, you don't need to write the 1 in front of it. It's assumed that there's a 1 in front of it. You don't need to write the 1 exponent. It's assumed that it has an exponent of 1 by you not writing it. Okay? So, let's see. We just did this. Okay. I'm going to kind of skip past that. That kind of defines how we get our roots. So now, what I want to show you is that a radical is another way of writing an exponent that's a fraction. So we're actually going to be going back and forth between radical form and exponential form with a fractional exponent. Okay? Now, all three of these are kind of saying the same thing. And it might be a little bit overwhelming for you to look at something like that and try and figure out what it's saying, so I'm going to try and make it a little bit easier. But when you have a fractional exponent, the denominator of that fraction is equal to the index when you write it in radical form. The denominator of the fraction is equal to the index when you write it in radical form. So in this example right here, 25 is my base, therefore 25 is the number that goes in the radical. And the index would be 2. Do I write an index of 2? No. This one would be the 25 in there, but what would the index of this one be? Still a 2. Do you see that? Still a 2. I'm going to hold off on the next one for a minute. What was that?
If we write the 2, will you mark it wrong?
I won't mark it wrong, but it looks kind of elementary. Same way this looks elementary. We don't write 1x. We just write x. Okay? Yeah. So let's see. How are these two different? Because this was 1/2 and this was 3/2, and currently they look the same, don't they?
Yes.
So I got to tell you where the numerator goes. The numerator is an exponent. So I prefer to put the exponent out here. So this one would have an exponent of 1, which technically you don't have to write the exponent of 1, but I'll solve it in a minute. What would the exponent here be? Now my problems look different. Now, what this was saying over here is there's actually a couple different places you could put that exponent, and it still means the same thing. So this one could be written as the square root of 25, and you could put the 1 exponent inside, and that means the same thing as having the 1 exponent outside. With the 3, this would look like this. So it could have the 3 inside the radical, and that means the same thing as having the 3 outside the radical. Okay? Now, looking at one of these ways, well, let me step back for a minute. This one also could be written as 25 under the radical with no exponent, because an exponent of 1 we don't need to write. So what does that end up simplifying to? 5. So 25 to the 1/2 power is another way of saying what's the square root of 25. So you should be getting to the point by the end of this lesson that if I asked you, what's 81 to the 1/2 power? You should be able to say 9 without too much thought. Because 1/2 power just means you're taking the square root. Okay? Now, this one, I'm not just taking the square root, but I'm also cubing it. Now, there's two different ways to look at this as far as the exponent is concerned, but one of these to me is easier to solve, even though they both give me the same answer. And it has to do with the fact that I don't happen to know what 25 to the 3rd power is off the top of my head. Do you? Not without getting your calculator out, most likely, right? It's a pretty big number. So I don't want to do this one where I have to cube 25 first. I would rather do this one where I square root 25 first, because that I can do in my head. What does that give me? 5. And if I took that 5 and raised it to the 3rd power, I get what? Now, just a minute and I'll get your question. If I were to double check this method right here, and I did 25 to the 3rd power, which is a big number like I expected, and I took the square root of 15,625, I still get 125. So either way will get me to the correct answer, but one way may be easier to do without having to get your calculator out. Okay? Yes?
When we're doing a worksheet or doing problems or something, is it absolutely necessary to write like 1 if it's an exponent?
Nope.
Right? Okay.
Nope. Okay, do you see the difference between these two ways of writing it, though?
Yes.
Makes you think about it a little bit differently. One way's easier. And sometimes it might be easier in exponent form. Who knows? We may come across that. All right, what's going on in this guy?
Negative.
Negative. What does that mean?
Close the numerator.
What does a negative exponent mean?
Close the numerator.
Fraction.
It means we have a fraction. Do you remember this? When you had something like this?
Oh, one over.
Yeah.
Oh my God.
A negative exponent does not make anything negative. It makes it a fraction. So before I do anything as far as changing that to radical form, I would call this 1 over 32 to the 2/5. Now I can go to radical form. What would my index be? The number out front, what would the index be? 5. And again, I could write the squared like that, or I could write it like this. I don't really want to do 32 squared because that's going to be a big number. But the 5th root of 32 I could guess. 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 times. So the 5th root of 32 is 2. And 2 squared is
4.
So this ends up being 1/4. By the way, how would I find out if I didn't know what the 5th root of 32 was off the top of my head? Calculator. How do you find a 5th root on a calculator? How? If I want a 5th root, I'm going to type a 5 in. And then I know I explained this on a previous video, but there's this X radical button. So as soon as I get that, and I have something that says 5x radical, that's asking for a 5th root. If I wanted a cube root, I would change that 5 to a 3. If I wanted a 10th root, I would change the 5 to a 10. That's how I would calculate the 5th root of 32 is 2. Okay? All right. So for the most part of this lesson, we are going to be going back and forth from radical form to exponent form based on what's given to us here. So it's basically written as a chart, and we're going to just kind of fill in the blanks of this chart. Okay? So here is our first example, all with letters. You can put your exponent inside or outside, but when you go to exponent form, it's the numerator, and the index is what becomes the denominator. Okay? So if I had that with numbers, the other way of writing it in radical form would be to put the radical itself in parentheses and put the exponent outside. Correct?
Yes.
How would I write this as a fractional exponent? This would be x to the what power? 5/3. Remember, the index has to be the denominator. The exponent has to be the numerator. Is that something I can simplify? Not unless I know what x is. Okay? All right, next one's a trick one. I could write this without the parentheses and put the 12 inside. Is this what it would look like?
Yes.
Nope.
No.
X12, Y12.
I could write it like that. Or, since the 12 is outside the parentheses, it's applying to everything inside, meaning that it's applying to both the x and the y. As I have it written here, is it applying to both the x and the y?
No, it's only
Nope. It's only applying to the y. So, if I put parentheses right there, now it's applying to both the x and the y.
Mind blown.
Okay? It's a little thing, but it changes the meaning of the problem. So it's an important thing. Now, if I were to write this as a fractional exponent, what would the fraction be? 12/3. Huh. 12/3 can be reduced, can it?
Yes.
I'll reduce it in a minute, but as it's written right now, is it true?
No, yeah.
Have to put the parentheses around again if I want it to count for that x also. So I would actually write this as xy to the 4th. So this one was actually easier to see that it could simplify once you had it in exponent form.
Do we write that in the simplified box?
Well, here's how I would write it completely simplified. Because completely simplified, we don't want parentheses if we can avoid it. I would write it x to the 4th, y to the 4th. Or to the 5th. Let's see if I can write what I'm trying to write. There we go. That's how it would be completely simplified. Okay? All right, 27 to the 1/3. In radical form, what does that look like? What's my index? 27 goes underneath, but what's the index?
3.
3. What's the exponent?
1.
Do I need to write an exponent of 1? No, and that's why there's only one box, because with an exponent of 1, it doesn't matter. So how would I simplify that? What's my answer? 3. So you should be getting fluent with the fact that something to the 1/3 power is asking for a cube root, in the same way that something to the 1/2 power is asking for a square root. Okay? All right, 5th root of 25, what's that going to be?
25 1/5.
25 to the 1/5 power. Can I simplify that?
Yes.
No.
Yes, you can.
I can divide 25 by 5, but that's not dealing with an exponent. That's just doing plain old division. So there's nothing I can do there. If it was to the 1/2 power, yes, I could do something. 1/5, no good. Okay? All right, another trick one. I have the exponent outside. If I wanted to write the exponent inside, is this what it would look like?
No, because you can't fraction.
No.
You can have a fraction. Is this what it would look like?
No.
Why not?
Because it's only applying to F.
It's only applying to the F. Shouldn't it apply to the 64 also?
Yes.
So once again, we need parentheses there. Another trick question. In exponential form, what would my exponent be?
3 halves.
One more time.
2/3.
2/3. And again, if I don't put parentheses, that is wrong. It must have parentheses, because without the parentheses, it's only going to the F, not to the 64. So, if I wanted to simplify this, I would write it like this. Because we don't like parentheses in our simplified form. But I think I can do something with 64 to the 2/3. How do I know this? Well, because I know that 2/3 means it has an index of 3, which is a cube root. And 64 is a number you can take the cube root of. So let's think about this for a minute. That would be the cube root of 64 squared. What is the cube root of 64?
4.
Squared is?
16.
So I would actually call this F to the 2/3 over 16. That would be your fully simplified answer. Okay, so?
Yes.
Good answer. All right, 243 to the 1/5. What's the index? 5. What's the exponent?
Nothing.
1. Do I need to write it? Nope. Now, I don't happen to know if this is going to be a nice number or not yet. So I'm going to go to my calculator and practice that 5th root thing. Happen to already have a 5th root there, but the 5th root of 243. Any guesses?
3.
It's 3. Now, if I don't trust that my fingers typed in the right thing, what could I do to check that?
3.
I could see if 3 to the 5th equals 243. So 3 to the 5th, yep, 243. Okay. All right, 216. What is the index?
2.
Do I need to write it?
No.
No, you don't write an index of 2. What's the exponent?
1.
1. Do I write it?
No.
Nope, because you don't need to write an exponent of 1. Is the square root of 216 a nice number?
Yes. No.
Let's check. Nope, not a nice number. But it can be simplified. Do you remember doing this many, many moons ago?
Oh.
Remember this? What am I circling?
The prime.
The prime numbers.
Oh.
And I'm running out of room, so this branch is going sideways. Now, what am I looking for to take out of the radical? Pairs. Any idea why I'm looking for pairs?
So you can match it.
The reason why I'm looking for pairs is because the index is 2. If it was a cube root, I would need 3 of a kind to take something out. A 4th root, I would need 4 of a kind to take something out. And so on. So what can I take out? I can take out a 2 and a 3. And so if I write the 2 and the 3, whoops, I get 23, right? No, that would just be dumb. I'm going to multiply those. Inside, what's left? A 2 and a 3. Again, I get 23. No, that's dumb. I get 6 radical 6. Okay? So? Okay. Turning the page. All right, negative 64 to the 1/3. That would be a negative 64 under the radical. What would my index be? 3. Exponent? 1. And I don't need to write an exponent of 1. What is the cube root of negative 64? Negative 4. Okay? Square root of negative 64. That would be parentheses negative 64 to the what power? 1/2. Anyone happen to know what that is? It's 8i. We're not going to deal with i's though, so I don't want you to worry about that. For now, I would just say we can't have an answer yet, because we're just going to stick with real numbers. Now, what's the difference between this one and the next one? The negative is outside the parentheses, which means that it's going to be outside the radical. What's the index? 2. What's the exponent?
1.
Neither of which I need to write. So this one, I have the square root of 64, which I know is 8, and then I have a negative out in front. So my answer is negative 8. Okay?
What is this? Garbage.
All right, next one's one of my favorites. It's actually really ugly in exponential form, and there's a couple different ways you could write it. But 343 r to the 3rd, q to the 15th, all to the 3rd is kind of ugly. Here's how I would think of it. I would think it as the cube root of 343 times the cube root of r to the 3rd times the cube root of q to the 15th. Just breaking up each term or each part into its own radical so I can simplify them individually. Cube root of 343, anyone know what that is? Cube root of 343 is 7. So this whole part just becomes 7. What do you think happens here? Cube root cancels out of cubed, and I'm just left with r. So now I just got to deal with this one. Now, I'm going to talk you through this one. There's a long way and a short way to think about it. I'm going to start off showing you the long way, and then I'll explain the short way. Q to the 15th means I've got 5, 10, 15 under a cube root, right? As I said, this is a long way of thinking about it. Now, since it's a cube root, I need 3 of a kind to take one out. 3 of a kind to take one out. 3 of a kind to take one out. 3 of a kind. 3 of a kind, and there's no loners left inside. So what am I left with? Q to the 5th. What's the shortcut way of thinking about that? 15 divided by 3 is 5. Now, that's great, except when that exponent's a 14, then it's an issue. If that exponent was a 14, what would that mean? I would have 4 q's that could come out, but I would have 2 q's left inside, right? So it gets a little messier there. So let's see. I'm down to 7r q to the 5th. Now, if it was q to the 14, let me show you how it would be. q to the 14th. How many groups of 3 are in 14?
4.
There are 4 groups of 3. That means 4 can come out. How many are left at home that do not make a group of 3? There are 2 loners. That's the exponent inside. Okay? You would have 4 groups of 3, meaning you're removing 12 of those 14 q's. And that gives you 4 groups of 3. But then you've got 2 q's left inside because they don't have a full group to leave. Okay? They're loners. All right. Square root of 5 to the 4th. That could be written as the square root of 5 to the 4th like that. What would that be written like as an exponent? 5 to the 4 over 2. Huh. Over here it was a little harder to see, but here, that's 5 to the what? Which is 25. Okay. 4th root of 3 to the 2nd. Again, that can be written as 4th root of 3 to the 2nd. As an exponent, that's 3 to the what? 2 over 4. Can that be simplified?
Yes.
What is it?
1/2.
3 to the 1/2. Can I solve 3 to the 1/2? Nope. Square root of 3 isn't a nice number. Okay. Next one, square root of 25 cubed. I think I did this one on the previous page. Remember, I don't want to cube 25 because it's a big number. Yeah?
Yes.
So square root of 25 to the 3rd. Okay, as an exponent, that would be 25 to the what? 3 over 2. Now, what form is it easiest to find the answer from? The first, second, or third? Second, because the square root of 25 is 5 to the 3rd power is 125. Negative 5 to the 10/5 could be the 5th root of negative 5 to the 10th, or the 5th root of negative 5 to the 10th, but the negative 5 has to be in parentheses. Same reason why when we had the x and the y on the previous page, we had to have the parentheses. What is 10 over 5? 2. So this is really negative 5 to the 2nd power, which is what? 25. All right, square root of 4 to the 3rd. That could be written as the square root of 4 to the 3rd. As an exponent, that would be 4 to the what? 3 over 2. And that ends up simplifying. I think it's easiest to look at here. What's the square root of 4? 2. Raised to the 3rd power is 8. Okay, trick question here. Trick question. What's the trick here? There's no parentheses. What does that mean? It's only, the exponent is only applying to the b, which means that the c has to be outside any radical that I put. What's the index of the radical? 3. And the exponent? Squared. So over here it would look like c times the cube root of b squared. Now this is one where you will have to be careful with your writing, because the index here can often look like an exponent on the c if you're not careful with how you write. So tuck that index right into that radical so it doesn't get mistaken for c to the 3rd times the square root of something. Okay? And that one can't be simplified. We're stuck with that one. All right, we got another negative exponent. What do I do with a negative exponent? Fraction. So that's 1 over, what is the index? Negative does not go in the problem. As soon as you make it a fraction, the negative goes away. If you wrote it this way, it would be the cube root of 8 squared. I think this one you could solve either way fairly reasonably, because 8 squared is 64, and this cube root of 64 is 4. Or if you went this way, the cube root of 8 is 2, raised to the second is 4. Either way, you get 1 over 4. Questions? Okay, this next part you can read through on your own, but these true-false questions are good at the bottom here. Okay? So, number 1, 1024 to the n over m represents the mth root of the nth power of 1024. That is a mouthful to say. Holy moly. Okay, I'm going to ignore this part right now, and let's try and translate this into something we can read. Okay? Clearly 1024 is the number that would be under the radical. Which part, do you think it's the mth or the nth, is representing the index? M. Because this one's the power, which means it's the exponent. Is this the way this would be translated? Do they have the index and the exponent matching to what it should be here? Yes. So is that statement true or false? True. It is true. Okay. Is the expression, or in the expression, negative 16x to the 2/3, 2 is the index? True or false?
False.
What is the index?
3.
Uh-huh. Index would be 3, not 2. 50 to the negative 3/4 power is equal to negative 50 to the positive 3/4 power. True or false?
False.
Why?
Because the negative is separate.
A negative exponent does not put a negative into the problem. It puts a fraction into the problem. Why was this true-false question put there? Because 50% of people, when we get to the test, somehow think that a negative exponent puts a negative into the problem. They completely forget that it makes a fraction. Don't be one of those people. Okay? And the last one, true or false?
Oh, false.
What would make it true?
The XY function.
If the 3/2 was on both of them, or if that was in parentheses. Because without the parentheses, it's only applying to the y, not the x as well.
Let's just say we can't have parentheses in the answer. Or we should-
I'm not asking you to simplify it, I'm just asking you to tell me if it's true or false. Okay? All right, so your homework tonight is right here. I will put the textbook page up on Google Classroom so that you can see it there.